Okay, hello everyone, in a new video. So we have reached part 10 of chapter 5, which is the chapter of kinematics for grade 11 students. So now in this part we are going to solve or continue solving exercises. So they are telling me two particles A and B move in the space reference system OIJ for T is positive. The position vectors of particles A and B are given by R of A and R of B. So here notice that as for the particle A, so for the x-axis it's linear in time and for the y-axis it's linear in time, so it is URM in the x and in the y motion, and the same goes for R of B. Now in number 1 they are telling me determine the velocity vector and the acceleration vector for each particle at any instant, and this can be done by studying the type of motion along the x-axis and the y-axis. And here let me specify the equations of motions regarding one dimension. Then for the case of URM we have that x is equal to vt plus x0, v is equal to a constant, and the acceleration is equal to 0. As for the case of UVRM, we have that x is equal to half at square plus v0t plus x0, v is equal to at plus v0, and the acceleration is equal to a constant. So let's start by referring. So we need to do this analysis for both particles A and B. So let's start by particle A. Then motion along the x-axis. So as for the particle A, the parametric equations are given by, okay, without specifying the parametric equations, so let's say since x, so it's equal to t minus 2, verifies the general form, so because the position is linear in time, whenever the position is linear in time, this means that the type of motion is URM. Verifies the general form x is equal to vt plus x0, and here always you need to distinguish between components. Then the type of motion is URM. And in this case we can use the following equations that are given by x is equal to vt plus x0, v is equal to a constant, and the acceleration is equal to 0. So a of x, v of x, v of x. We are interested in determining the velocity vector and the acceleration vector. So the velocity vector is given by vxi plus vyj. As for the acceleration vector, it's given by axi plus ayj. And in this case the given form is given by x is equal to t minus 2. So comparing linear terms, we can see that v of x is equal to 1. Then by comparison, v of x is equal to 1 meter per second. And because we are interested in the acceleration, let me state here that a of x is equal to 0. So this is for the x-axis for the particle A. Now as for the y-axis, so in this case we have since y is equal to t minus 2 to the power 2. So here notice that I have said that it is linear, but this is not linear here because we have power 2. So since x is equal to t minus 2 to the power 2, so here we have power 2, so it's not linear, it's quadratic, okay? So this gives us it's equal to t squared minus 4t plus 4 if we expand and reduce. Verifies the general form. So because this is quadratic in time, sorry, here we are talking about y. Since it's quadratic in time, whenever the position is quadratic in time, this means its UV around verifies the general form y is equal to half ayt squared plus v0yt plus y0. Then the type of motion is UV around. And in this case, we can use directly the following equations that are given by y is equal to half ayt squared plus v0yt plus y0. As for the speed along the x-axis is given by ayt plus v0y, and ay is equal to a constant. The given equation is given by y is equal to t squared minus 4t plus 4. So by comparison, in order to determine Vy, we need to determine Ay and V0y. So comparing quadratic terms in the position, we get that half Ay is equal to 1, which means that Ay is equal to 2 meters per second square. And as for V0y, comparing the linear term, we get that V0y is equal to minus 4 meters per second. So in this case, the speed is given by Vy is equal to 2t minus 4. And as for the acceleration along the y-axis is given by 2 meters per second square. Now in this case, the velocity vector is given by 1 multiplied by the unit vector I plus 2t minus 4 multiplied by the unit vector j. Now so this is for the particle A. As for the acceleration for the particle A, along the x-axis it's 0, and along the y-axis it's given by 2. So this is equal to 2j. So these are the velocity and the accelerations of the particle A. So notice that this velocity is the instantaneous velocity because it explicitly depends on time. Now we need to do the same analysis but for the particle B. And let's start by the motion along the x-axis. Since x is equal to 3t over 2 minus 4, so because the position is linear in time, this means that the type of motion is URM, verifies the general form. X is equal to Vxt plus V0. Then the type of motion, so here let me say along the y-axis also. And along the x-axis. Then the type of motion is URM along the x-axis. And in this case we can use that x is equal to Vxt plus x0. Vx is equal to a constant and the acceleration along the x-axis is equal to 0. And we have that x is equal to 3 over 2t minus 4. So by comparison, comparing linear terms, we can see that Vx is equal to 3 over 2 meters per second. And A of x is equal to 0. Now as for the motion along the y-axis, we have that since y is equal to 3 over 2t minus 2, if I'm not wrong. Yes. Verifies the general form. Y is equal to vyt plus y0. Then the type of motion is URM along the y-axis. So in this case we can directly use the following equations that are given by y is equal to vyt plus y0, vy is equal to a constant, and ay is equal to a 0, and we have that y is equal to 3 over 2 t minus 2. Then by comparison we have that Vy is equal to 3 over 2 meters per second and Ay is equal to 0. So in this case now we can express the velocity of the particle B, which is given by Vx, which is equal to 3 over 2I plus 3 over 2J, and as for the acceleration, it's given by 0 along the x and along the y, so it's 0I plus 0J, which is equal to 0. Notice that this is a vector quantity, so vectors must exist on the left and on the right. Okay. Now in number 2, they are telling me determine the time at which the particles collide. So by determine the time we need to find t at which the particle collides. So this statement is important and we need to translate it into mathematical formula or to a constraint equations that are, when we solve this equation we will find t, so an equation as function of t. So what does it mean that the particle collides? The word collide means that they hit each other. So suppose this is the particle A and this is the particle B. So by collide it means that they hit each other, so they are found at the same position. Whenever they are found in the same position, we can say that the position vector of A is equal to the position vector of B. Okay, so by collide it means that they hit each other, and this is given by that the position vector at the point A is equal to the position vector at the point B. So t minus 2 I plus t minus 2 to the power 2j is equal to 3t over 2 minus 4 I plus 3t over 2 minus 2j. So this is a vectorial equation. What's the solution of this equation? In order to solve this equation, we need to equate between the x component and the y component. So this will give us two equations. The first one is given by t minus 2. So the x component is equal to the x component, so 3 over 2 t minus 4, and the y component is equal to the y component, so t minus 2 is equal to the power 2 is equal to 3t over 2 minus 2. So this is equation number 1 and this is equation number 2. We need to solve both equations simultaneously, and any value of t which is less than 1, which is negative, is rejected because time is always positive, and moreover here they are telling me for t is positive. Okay, so considering equation number 1, which is given by t minus 2 is equal to 3 over 2 t minus 4. So what's the type of this equation? This is a linear equation, one unknown. How do you solve it? We put t on one side and all the other numbers on the other side. So it's given by 1 minus 3 over 2 multiplied by t is equal to minus 4 plus 2. So 1 minus 3 over 2 is given by minus half t, which is equal to minus 2. Then in this case t is equal to 4 seconds. So this is the solution from the first equation. Yet we cannot decide if this solution is accepted or no until we solve the second equation, okay? So after we solve the second equation, we will compare both solutions and then we will discuss. Because here in the second equation we expect that we have two solutions, and this is given by, because the type of equation is quadratic. Then moving on to equation number 2, which is given by t minus 2 to the power 2 is equal to 3 over 2 minus 2. So what's the type of this equation? This is an equation as function of t, which is quadratic, because here if you expand this, we will obtain t to the power 2. So there are several ways to solve this equation, but the straightforward, so the easiest way is to expand this and solve for delta. Then it's given by t square minus 4t plus 4 is equal to 3 over 2t minus 2. Then t square plus minus 4 minus 3 over 2 multiplied by t plus 6 is equal to 0. So then this is given by t square plus, so minus 4 minus 3 over 2, it's given by minus 11 over 2. T plus 6 is equal to 0. Then we can find the value of delta. Then after finding the value of delta, or using the calculator, we can check that one of the solutions is given by t is equal to 4 seconds, and the other solution, so here it is or. So as you can see that this equation, the type of this equation is quadratic because it has the power 2, and the other solution is given by t2 is equal to 1.5 seconds. So now if you consider the fact that t is always positive, both solutions are accepted, but we will only consider this one to be accepted and this is rejected, simply because we are solving two equations at the same time. So both equations must have the same solution, and the same solution is given by t is equal to 4 seconds. Then we can safely say that the two particles will collide at t is equal to 4 seconds, okay? Because if you consider the instant t is equal to 1.5 seconds, then the x component t minus 2 will not be equal to 3t over 2 minus 4, okay? So the accepted solution is given by t is equal to 4 seconds, because it's the same solution for equations 1 and 2. So this is it for exercise number 23. Now in exercise number 24, they are telling me the velocity vector of a moving object s taken as a particle in the reference system yj is given by v is equal to 2i plus 4t plus 1j. The motion starts at t0 equal to 0 seconds from the origin of the system. And this is important. Whenever they tell me from the origin of the system, this means that x0 is equal to 0 and y0 is equal to 0, okay? Now number 1, they are telling me indicate the nature of motion of s along OI and OJ. So let me write here on the scratch the equations of URM and UVRM. Now let's start by specifying the type of motion along OI, which represents the x-axis. So notice that always unit vectors describes the axis, describing the line of action and direction. So motion of along OI so since v of x is equal to 2 meters per second, so whenever the speed is constant, then the type of motion is URM, verifies the general form, v of x is equal to constant, then the type of motion is URM. And now as for the motion along OJ, sorry. So since Vy is equal to 4t plus 1, and whenever the speed is linear in time, this means that the type of motion is UVRM, verifies the general form, here along the x-axis, Vy is equal to, okay, Ayt plus V0y, then the type of motion is UVRM along the y-axis. Okay, so now in number 2 they are telling me determine the position vector of S at an instant, and the position vector is given by R is equal to xi plus yj. In order to determine this position vector, we need to determine x and y explicitly as function of time. So let's start by the x-axis. Now since the type of motion is URM, then we can say that x is equal to Vt plus x0, V of x is equal to a constant, and A of x is equal to 0, and given that the general form of V of x is equal to 3 meters per second, so okay, so in this case x is equal to 3t plus x0, but notice that the value of x0 is given here, since it's starting from the origin that x0 is equal to 0. So this is 3t plus 0, then x is equal to 3t. Now as for the y-axis, since the type of motion is UVRM, then we can write the following equations that are given by y is equal to half Ayt square plus V0yt plus y0, Vy is equal to Ayt plus V0y, and Ay is equal to a constant, given that Vy is equal to 4t plus 1, then by comparison, now notice that we are interested in determining y. For this we need to determine Ay, V0y, y0. So first let's start by determining Ay, and this is done by comparing speeds. Considering the linear term, we have that Ay is equal to 4 meters per second square, and V0y is equal to 1 meter per second. Moreover, the initial position along the y-axis is given by 0. So in this case, y is equal to half 4t square plus t plus 0. So it's given by 2t square plus t. So y is equal to 2t square plus t. Now we are ready to express the position vector, which is given by r is equal to 3ti plus 2t square plus t j. Now in number 3 they are telling me find the trajectory equation, then deduce the trajectory described by S, and this done by finding an equation which relates X and Y. So what does the trajectory represent? It represents the actual path of the moving particle. So now this can be done by referring to the parametric equations after we have determined the position vector. So in this case X is equal to 3t and Y is equal to 2t squared plus t. Now referring to the linear term, we have t is equal to x divided by 3. Then let's replace in y. So in this case we have that y is equal to 2 multiplied by x over 3 raised to the power 2 plus x over 3. And since it is linear in one variable and quadratic in the other, then the trajectory described by this particle is given by parabola. Now as for the part 4, they are telling me determine the acceleration vector, which is given by axi. The value of ax along the x-axis is given by 0, and as for the y-axis it's given by 4. So it's simply given by 0i plus 4j, which is equal to 4j. Then the acceleration vector is given by 4j. For sure the unit of acceleration is meter per second squared. Now in part 5 they are telling me write the expression of the speed of s at the instant t, and notice that the speed is the magnitude of the velocity. We have already determined the velocity, or we have the velocity at any instant, which is given by this. So 2i plus 4t plus 1j. Then this is a vector quantity having 4 properties: point of application, line of action, direction, and the magnitude. The magnitude of any vector, we drop down the vector and we take the square root of the sum of the components raised to the power 2. So v in this case is given by square root of v of x squared plus v of y squared, which is equal to square root of 2 to the power 2 plus 4t plus 1 to the power 2. So this is the speed, and no need to expand and reduce what is inside the radical. So indeed this is the expression of the speed at an instant. It is the instantaneous speed because the time appears explicitly in this equation. Okay. Now as for the final exercise number 25, they are telling me a particle M moves in the space reference system OIJ. The adjacent graph, so they mentioned this graph, now we can use it, represents the variation of the ordinate y as function of the abscissa x of M. So always the variation is labeled on the y-axis and the function is labeled on the x-axis. Notice that these x and y are different than those than those we use in mathematics because they carry quantities. So this is the position and this is the position. So what does this curve represent? Since it is a relation between y and x, it represents the trajectory. Now in number 1 they are telling me to determine the trajectory equation. Okay, so in other words we need to determine the equation of this straight line. So the equation of this straight line is given by y is equal to ax plus b. So a is the slope and b is the y-intercept. Okay, so the equation of straight line is always given by the quantity on the y-axis, which is equal to the slope multiplied by the quantity on the x-axis plus the y-intercept. Okay, so this doesn't represent the acceleration, this is the slope. Okay, now in this case, in order to determine the slope, it's sufficient to consider 2 points. So let's consider the point A, which is given by 0, 2, and let's consider the point B, which is given by 3, 6. Then the slope A is given by ya minus yb divided by xa minus xb. So the value of ya is given by 2, the value of yb is given by 6. Now here we expect that the slope must be positive because notice that this is a straight line with a positive slope, which is increasing. So how do we read a curve? We read it from left to right. As we read it from left to right, we notice that this straight line is increasing upward. Okay, so we expect that the slope is positive. Now x of a is 0 minus x of b, which is 3. So this is equal to minus 4 divided by minus 3, which is equal to 4 over 3. Okay, so always in physics, all quantities must have unit. Here we can simply place SI, or if you are interested in the unit of the slope, notice that this is expressed in meters and this is in meters, so YA minus YB is in meters. As for XA minus XB, this is in meters and this is in meters, so this is expressed in meters. Meters with meters goes out, so A is unitless. Okay, it happened in this case that A is unitless or dimensionless. Now, as for the y-intercept B, so B is the y-intercept. It's the value in which the straight line passes through the y-axis, and this is given by the value which is 2. So B is equal to 2. Now, in this case, B carries a unit which is meters. So B is equal to 2 meters. Now, in this case, the equation of the trajectory is given by y is equal to 4 over 3x plus 2. Okay, for x is equal to 3. So, okay. So this is the equation of the trajectory. And notice that previously we used to determine the equation of the trajectory having the parametric equations, okay? But in this case, we have determined the trajectory equation by referring to the graph. So now in number 2, they are telling me the motion along the x-axis is uniform rectilinear motion with speed v of x is equal to 2 meters per second. And here, because they are specifying type of motions, let me write on the scratch that in the case of URM, we have that v is equal to xt plus v0, v is equal to a constant and acceleration is equal to a 0. As for UVRM, we have that x is equal to half at squared plus v0t plus x0, v is equal to at plus v0, and a is equal to a constant. So they are telling me in part 2, URM along the x-axis and v of x is equal to 2 meters per second. Okay, and now in part A they are telling me write the time equation xt knowing that the motion starts from the origin at t0 equal to 0 second. Starting from the origin means that the initial position is given by x0 is equal to 0. We are interested in determining x of t or writing the equation x of t. So let's say since the type of motion is URM along the x-axis, then we have that x, sorry, this is x. Then we have that x is equal to xt, sorry, this is vt plus x0 Then time is always considered as a variable. In order to determine x, we need to determine v and x0. So this is vx because we need to distinguish between different components. Notice that vx is equal to 2 and x0 is equal to 0. Then the time equation is given by 2t plus 0, which is equal to 2t. So x is equal to 2t. Now in part B, they are telling me determine the time equation yt. So we need to determine the equation yt, okay? So notice that here we don't have any information about the type of motion along the y-axis, so we cannot determine y as we have determined x. But notice that here we have the trajectory equation which relates y and x. Since we know x in terms of time, we can replace it in y to determine y. Then in this case, y is equal to 4 over 3x plus 2, but x is equal to 2t, so it's equal to 4 over 3 multiplied by 2t plus 2, which is equal to 8t over 3 plus 2. So in this case, y is equal to 8 over 3t plus 2. And this is expected. Why? Because whenever x and y are linear in time, the trajectory is given by a straight line. So now in number 3, they are telling me write the position vector of m at any instant. This is straightforward after we have determined the position along the x and along the y. So by definition, the position vector is given by xi plus yj. So this is a vector quantity. Vectors must exist on the left and on the right. This is 2t multiplied by I plus 8 over 3t plus 2j. Then the position vector r is given by 2ti plus 8 over 3t plus 2j. Now in number 4, they are telling me determine the velocity of m at the instant t. Then the velocity vector v is given by vxi plus vyj. We know that vx previously we have determined, and it's given by, or it's given by 2 meters per second, and because the type of motion is URM, then v is equal to a constant. So Vx is equal to 3 meters per second. Now it's left to determine Vy, and Vy can be determined by studying the motion along the y-axis. Notice that till this moment we didn't study the motion along the y-axis. So motion along the y-axis so we didn't specify that it is URM. So let's say since y that we have determined is given by 8 over 3 t plus 2 verifies the general form, which is given by y is equal to vy t plus v0y. Then the type of motion is URM along the y-axis because it's linear in time. Comparing it with this equation, it is URM. Then in this case we have that y is equal to vyt plus y0, vy is equal to a constant, and the acceleration ay is equal to 0. We have that y is equal to 8 over 3t plus 2. Then by comparison we get that Vy is equal to 8 over 3 meters per second, comparing linear terms in both members, this with this. So now in this case Vy is 8 over 3 meters per second, and the velocity is given by 3i plus 8 over 3j. Now in number 5, they are telling me calculate the speed of m at the instant t is equal to 2 seconds. In order to calculate the speed of m at the instant t is equal to 2 seconds, we need to find the expression of speed as function of time. Knowing that we have determined the velocity, so here although the velocity is independent of time, but it depends on time, and this is because v is equal to a constant, okay? So now we are in part 5. So this has 4 properties: point of application, line of action, direction, and magnitude. The magnitude, which is given by v is equal to vx square plus vy square, represents the speed. So v is equal to square root of vx square plus vy square, which is given by square root of 3 to the power 2 plus 8 over 3 to the power 2. And here it's convenient to expand and reduce because it's independent of time. So square root of 3 to the power 2 plus 8 over 3 to the power 2, so this is equal to almost 4.01 meters per second, and this value of the speed is constant at all times, and in particular for v given by the instant, so let me say that the speed is given by 4.01 meters per second at all times. So in this case, the speed at the instant t is equal to 2 seconds is equal to 4.01 meters per second, which is constant at all times. Now as for number 6, they are telling me determine the acceleration at any time. Notice that by referring to the type of motions along each axis, so since it is URM along the x-axis, then A of x is equal to 0, and URM along the y-axis, then A of y is equal to 0. Then we can say that A is equal to AXI plus AYJ, which is equal to 0i plus 0j, which is equal to 0 vector, URM along the x and y. So the acceleration vector is equal to 0 vector, okay? And notice that vectors must exist on the left and on the right. So that's it for me in this video, guys, and the next part will complete explanation of this chapter.